Okay, so we're doing MVF E4 here. So, oh gosh, excuse me. So we're starting with the fact that the unit sphere is the solution set to that equation. And so your question was about what order I go in. What's the order of the steps? So let's first write down some algebra here. So we're starting with this equation. And we want to do a series of algebraic sort of replacements, substitutions, things that we know what the geometric consequences are, right? So this corresponds to this picture, by the way. And the idea is if I can think of a series of algebraic steps, and if I know what the corresponding transformations are over here, then I can draw the corresponding picture. So, okay, let's just do the algebra first. We'll fill in the pictures later. The first thing I'm going to do is I'm going to replace everywhere I see an x, I'm going to replace that with x plus 6. And that seems backwards. You'll see why in just a second. And by the way, at the same time, I'm going to replace y with y minus 2. Because those don't affect each other. And, oh, sorry, that's part of the process there. Yeah. Okay. So in doing that, the equation becomes x plus 6 squared plus y minus 2 squared plus z squared is equal to 1. Now the next thing I'm going to do is I look at this equation, and I look at what I'm supposed to be getting to, and really I just need that x instead to be a 3x. So I'm going to replace x with 3x. And likewise, let's see, is that all actually? Oh, well, I need z. Yeah. Now here's this is easy to mess up. I need z to be 2z.
Oh, 2z?
I'll show you why in a second.
Oh.
So keep in mind, it's the actual z itself, not sort of what z is doing in the equation. So so what had been z, that's what's going to turn into 2z, and therefore the 2 gets squared to become the 4. So you have to be careful with that, right? If we had put a 4 here, then it would end up being a 16, and that's not what we're looking for. Now, what about the x business? Well, everywhere I had an x, namely here, I'm going to put instead 3x. So that makes this a 3x. Right. And that's it. So the y business stays the same. Okay. Now this is the equation we wanted. So that's what we want. Okay. Now it's tempting to go in the other order, but what you want to keep in mind is that if I were to put the 3 here first, I don't want to get in my own way there. So let me say hypothetically, if I were to start by replacing x with 3x, then I would get 3x squared plus other stuff. And then if I were to then replace x with x plus 6, then what happens is, what that x was, that's where you put the x plus 6. Everything that had happened to the x happens to the new x replacement, namely x plus 6, and you get 3x plus 18, and that's not what you want. Right? So unless you want to sort of deal with that direct, one thing you could do is replace x with x plus 2, and then this would be a 2, and then you'd have, it'd be 3x plus 3 times 2, which is 6, which would be fine. But you had to kind of deduce the idea there. So unless you want to deal with that, the moral of the story is you go kind of in the opposite of order of operations. Do your addition substitution first, and then do the multiplication after that. And the reason why is because, again, you're really kind of reverse engineering thing. When you multiply this out, the first thing you do is you take the x and you multiply it by 3. That happens first, so it needs to be the closest operation to this. Namely, it needs to come after this one. The process is just kind of intrinsically backwards. Yeah, it's just a little confusing, but honestly, once you sort of just realize that it's always the opposite of what you think, then, Works out, yeah. Okay, now let's finish this problem. What do we know happens here? Well, this, excuse me. So this, well, I'll say it this way. This process here corresponds to a translation. And so the sphere here, it gets translated by -6 in the x direction, +2 in the y direction. So it gets to move way back sort of over here. Like that.
And you represent that like new translation by like a position vector, right? So
I'm sorry?
You can relate like the translation by like a position vector. You know, like
Yeah, I mean, I could say that.
Like that
Yeah.
translated by.
Yeah, I mean, so I can just talk about what the coordinates of that point are. This is a -6 on the x-axis and 2 on the y-axis.
Gotcha.
Yep. And the radius is still 1 now, mind you. Okay. All right, now the next thing that happens, what does this process here correspond to? Well, there's a couple things happening there. There's a couple of squishes happening here. So there's a squish by a factor of 3 in the x direction and by a factor of 2 in the z direction. So squish. And yeah, this is going to be a little hard to draw, but keep in mind what we mean by a squish is that all of the x coordinates are going to shrink by a factor of 3. And that means that this center that had been at -6, well, that's now at -2. And let's see here, yeah. So there's a squish by a factor of 2 in the z direction. Well, that doesn't change the center of this at all, right? It just sort of squishes it down, but the center, I mean, the z coordinate doesn't change because the z coordinate was 0. So this center ends being up at -2, 2, 0. And now, but what about the radii? Well, it's no longer a sphere because I've squished it in one direction and squished it in another direction. So this new thing, it's got a, it's kind of like this, sort of it's shaped like a roll of French bread. So it's kind of long and skinny like this. So it's been shrunk by a factor of 3 in the x direction. So this, it's a hard thing to draw a picture of. In the y direction, the radius is still 1 because there hasn't been a squish in the y direction. In the x direction, that radius is now 1/3. And then in the z direction, nope, the z direction got squished by a factor of 2, so that is now 1/2. So can you sort of see how it's a roll of French bread?
Gotcha.
Yeah, because I'd say it's like a torpedo or something, but it's not because it's got different radii in those different directions. Yeah. Okay. All right. Let me stop this.
So for drawing these ones, we should write the radius is.
Yeah, I mean anything that is that's a good question. Anything that is relevant to the qualitative features of the thing, try to indicate in some way or another. And if you, I mean, I'm not artistically good enough to be able to draw in such a way that it's clear that this isn't just a perspective thing that makes this thing look oblong. That's not a circle. This has actually got different radii there. And so since I'm not talented enough to be able to draw that and have it be visually obvious, I have to say, hey, by the way, see that's 1/3 and that's 1/2. This is an artistic cop out, but that's okay. Right.